If anyone would like to ask any questions, I think there's a roving mic coming. Yes? It's very hard to see. Yep. So Charlotte's heading over. Thank you.
Not on.
Yes.
Is it on?
Yep.
My question to Pandora. You talked about higher frequency and more extreme weather events. It seems to me there are two possibilities in there. One is that winter rainfall. And my question really would be, in terms of if you have an extreme weather event and high rainfall, in terms of effectiveness, in terms of agricultural production and those sort of things, is that actually more useful to you than having lots of little bits of rainfall that dry up and disappear? And the second part of my question would be, what happens to things like cyclone frequencies under most of these models, in the sense that if you look at, say, Esperance, for example, in the goldfields, you used to frequently get cyclonic activity heading south right through to the south coast and generating summer rainfall.
I'll answer the second question first. So in terms of the projections for tropical cyclone frequency, they're projected to decrease in the Indian Ocean basin off the northwest of Australia, but the intensity, like the more intense storms, are projected to increase. So in terms of how far south they will then come, a lot of work's been done on their genesis, and that will shift a tiny bit south, but in terms of their progression after they're broken down and the impacts to the south, that hasn't been researched. In terms of your first question, I'm not an agricultural scientist, so I don't know how much impact these short, intense storms will have, but there might be other people that could answer.
That'll depend on when they occur. In terms of if you got a reasonable rainfall event at the break of season, that could certainly be an advantage, but it depends on, you don't want too much because some soils are very liable to waterlogging. So, you want a reasonable amount of rain, but huge rainfall events can be a problem. And with agriculture, everything is about timing, and the timing of a particular crop, and a particular soil type, and a particular farmer, because some farmers are sowing earlier than others. So it's very hard to say exactly how that's going to play out.
Sorry, one aspect from recent research I've done, which has not yet been published, we've been looking at the signature of these extreme upper tail events in rainfall on the daily timescale, and globally that's going to increase everywhere. That's the projection. But on the monthly timescale, so how much impact that has over a longer period, in the subtropics, so in this neck of the woods, we don't see that increase. It's just the large scale drying that influences on the sort of more monthly timescale. But as Julia said, it's really the timing of these short-term events.
Any other questions? No? Oh, sorry.
Oh, yes, Pandora. Do you have a preferred GCM for the southwest?
There are 8 GCMs that have been selected for use in the Climate Change in Australia website. So we've analysed 40 and then looked at how well each of those represent Australian climate. Now, a big aspect of that has been how well do they get the jet stream, the positioning of that north-south. So those 8 are actually reasonably good for the southwest. So play around with those 8, see which ones give you which scenarios, and you'll be on the right track.
I have a question for Pandora. Pandora, you said that our summer maximum were going down, or maybe not, certainly not going up. What about the minima? Because I thought that our summer minima were actually going up. That is correct. So what effect is that likely to have in terms of if we're getting much warmer night temperatures but cooler day temperatures in summer? I guess that's something that people need to think about in their planning. That although we're saying it's cooling, it's not cooling overall.
Yeah, that's absolutely correct. So the mean temperature is still going up. I mean, for me as a scientist, I sort of see these small anomalies and I jump on them because they're very interesting. But in terms of the large-scale kind of response, definitely everything's warming up. but there's this small area in the maximum temperatures that's going down in response to these more localised shifts in the circulation.
My question's for Pandora. You mentioned that this season's an ENSO event, and I was just wondering, with your research, are you involved with the predictions of how the frequency of ENSO events are going to play out with the most useful models, I suppose? Because I work in the marine area, and it affects a lot of the things that I've worked on, and it's quite interesting seeing how that's changing in the last sort of 40 years.
So there's an awful lot of research going on around how ENSO is going to change into the future. The first outcomes were that we're still a bit, it's uncertain. It seems like it's just going to continue happening, El Niño, La Niña, and the frequency will probably be about the same. In terms of the impacts, they will probably shift. There are some nice papers around that in terms of the rainfall across the Pacific, for instance, like the localised rainfall, the shape of El Niño. And there's certainly work in the Western Pacific warm pool and how that's going to change. Jackie Brown's done some great work if you want to follow that up. But huge area of research still.
Any other questions? Yep. Oh, Justin?
Can I butt in quickly?
You go first. Yeah.
Your observation on frosts or predicted frost was interesting. I found it interesting. I remember a presentation probably 3 years ago now that actually was predicting greater number of frosts, particularly in the eastern wheat belt, which from our perspective has an impact because if farmers have less money, they have less time and resources to actually put into protecting the broader environment as well as for sustainable farming. So can you sort of elaborate on the observation of fewer frosts and how that might reconcile with other places in WA?
So again, this is an area that we really want to expand upon, and the research that you heard was perhaps someone who has really focused on the observed record. The results shown on the Climate Change in Australia website are simply a change factor. So everything's warming up in that calculation, and so if things warm up, you get above 0 degrees, you don't have frosts. But I would argue that we need to look more closely at that. And so that's something that hopefully will be updated in the next round of projections, if ever that gets funded one day. But there's certainly, an area that we would like to look at a bit more. Yeah.
My question's for Pandora. You're taking quite an interest in sea level rise. Could you give us your thoughts on a new paper by James Hansen on his theory that sea level rise will double every 10 years, the rate of sea level rise?
Sorry, I'm not an oceanographer, so I haven't looked at this specifically myself. One thing I do seem to keep hearing as I go to various conferences is that they're constantly finding new sources of extra height, sea level height. As they do further research in this field, which is just going forward at a breakneck speed, they're finding that, say, in Antarctica, there's ways that the warmer ocean water can get in under the ice shelf and actually start to break things down more quickly than we ever thought was going to happen. So, yeah, I wouldn't be surprised if the rate of increase will increase exponentially, as you say. But I can't comment specifically on that paper.
Oh, hi. I've got lots of questions, but I'll direct the question to Julia. In your talk, you mentioned that we've got brief records for our region of climate metrics. I was wondering whether you're aware of the recent research done at UWA on the Calitris Pines near Salmon Gums that have proxy data that goes back to 1655, and their analysis shows that there are regular 50-year cycles in climate shift. So it's a very significant paper that it seems that very, very few people are aware of.
Craig, yeah, I'm aware of that, and I think that's why we say we don't exactly know what level of natural variability there is. We know that there's been a lot of drying cycles of drying and wetting in the past in Australia. That's well accepted. I think it's well accepted in the literature that there have been long-term drying and wetting phases, and we don't exactly know how much of the change, particularly on the west coast, that might have been natural variability and how much is greenhouse gases. And I'd put Pandora on to deal with that one, but I think some of the west coast drying could have been natural variability.
Absolutely. Yeah, natural variability is a big factor in all of this. The thing for the southwest corner of Australia is that the greenhouse gas signature is that things will shift south. There will be higher pressures predominantly in this region than there ever were before. So that signature is there. So whatever background variability you have is going to be on top of that background signature.
I just make a comment about sea level rise to the gentleman too. It's not only what's happening in the ocean and climate that affects sea levels, it's because continents actually tip. And Australia is actually banging into Indonesia at the moment. So we might actually be tipping up a bit. So long term.
We are still rebounding from the glaciers that used to sit on us too. So yes, longer term.
Okay. Thank you very much. That was excellent.